You may remember complex numbers like I or I squared, where I squared is equal to -1. That's a pretty important definition. But you may not be used to dealing with complex equations like this one that we have here. And look what it says. It says, what complex number is a solution? So that means we're going to solve for z. And when we get the answer, it's going to be one of these 5 on the left. It's going to be complex. Likely is going to be complex anyway. So let me show you how I would approach this one. I'm going to take this equation and modify it. Okay, and actually I suppose I should not go too fast. Let's start with the original equation as it's written. I'm going to show you what I'm going to do here. So there's our equation. Now I want to get z by itself. That's what it means to solve something. So I'm going to divide both sides by whatever is preventing z being by itself, which in this case is 3 plus 4i. Okay, those cross out, and now I have z equals this fraction, 3 plus 4i. Okay, now you'll notice that's a solution, but it's not on the left. And there is nothing I can do personally to recognize it on the left. I can't, for instance, just pick this one because it looks kind of the same. So we're going to have to do better than this. Notice that all of these things have a real number and an imaginary number, and they're separated, whereas what we have shows them together. So I'm going to use a technique called rationalizing. I'm going to multiply by the complex conjugate as a fraction where the numerator and the denominator are the same. That's allowed because this fraction that I just introduced there is equal to 1. It's the same thing on the top and bottom. So this is really like multiplying by 1. It just looks a little funny. Now let's work through what happens, and you're going to see something interesting. On the top, that's very easy. Let's just write that down. 1 times 3 minus 4i is just 3 minus 4i. On the bottom, that gets a little complicated. And what I'm going to do here, if you remember, this is a little bit of what's called foiling or distribution of multiplication. This is kind of what I'm dealing with. I'm going to take this problem, and if you remember how this goes, I'm going to multiply first term times first, second term times seconds. Then I'm going to come in here and multiply these ones likewise. Okay, now here's the result. Once all the math settles out, 3 times 3 is 9. 3 times -4i is -12i. 4i times 3 is plus 12i. And then I have 4i times -4i, so that's going to be a -16i squared. And now it's some cleanup time. So we're not too far from the end here. I'm going to move a little fast with this stuff. Notice that the sign on the 16 changes because that's an I squared and it flips the sign, which means this is going to be equal to 3 minus 4i over 25. So that's interesting. We see that 25 in the denominator, which is what all these answers had as an option. And what this turns into, if I separate this fraction, is 3 over 25 minus 4 over 25 times I. Okay, that's just me splitting up the numerator, which is an allowed trick that you can do with these things. And you see there, hopefully I've got an answer as my choice. Yep, there it is, right there. Okay, so this is called multiplying by a complex conjugate. That's a pretty useful trick right here. Anytime you see a denominator that is complex, you probably want to do that.